A positive 100 microcoulomb charge is placed at the origin and a negative 300 microcoulomb charge is placed 1 meter to the right of it. What is the magnitude and direction of the electric field midway between the two charges? And also on the second part, what is going to be the direction and magnitude of the electric field 20 centimeter to the right of the negative charge? So let's find out the direction and magnitude of electric field midway between these two charges first. So we have a positive charge in here and negative charge in here. The distance between these two is 1 meter, and we need to find out the electric field right in between. So we know electric field due to positive charge is gonna go going this way, and from the negative charge is gonna go also this way as well, because it's going toward negative and it's gonna go outward from positive charge. So that's gonna be E1 and E2 if we call this one Q1 and if we call this one Q2. So E net equals to E1 plus E2, and for sure it's going toward right. So E net will be it's going to be K Q1 over R squared plus K Q2 over R squared. K is constant, it's not changing, and R, these two R's are different. One of them is from here to here, and this R is going to be from here to here. But in this case, both of them are equal, because both of them are, since it's halfway through, it's going to be 0.5 in each of them. So it's better to factor it, and then we're going to have Q1 plus Q2. So E net will be 8.99 times 10 to the power of 9 divided by 0.5 to the power of 2, 100 times 10 to the power of negative 6 plus 300 times 10 to the power of negative 6, which will be 400 times 10 to the power of negative 6. So we have 8.99 times 10 to the power of 9 divided by 0.25, and here we have 4 times 10 to the power of negative 4, because 400 times 10 to the power of negative 6 is the same as 4 times 10 to the power of negative 4. So we have 8.99 times 10 to the power of 9 times 4 times 10 to the power of negative 4 divided by 0.25. So the answer will be 14384, or 1.4384 times 10 to the power of 1, 2, 3, 4 Newton per Coulomb, or if you want to round it, it's going to be 1.44 times 10 to the power of 4 Newton per Coulomb. This is going to be 7, not 4. 9 and negative 4, yeah, that's correct. So in the second part, we want to find out the electric field 20 centimeter to the right of the negative charge. So it's going to be somewhere here when we have 0.2 meters. That's Q1, Q2. So we have E1 going this way, and E2 is going to go toward the negative charge. So let's find out each of them. So E1 will be KQ1 over R squared, which is 8.99 times 10 to the power of 9 multiplied by Q1 is 100 times 10 to the power of negative 6 divided by the distance. The distance is going to be 1 plus 0.2, which is 1.2 to the power of 2. So that will be 8.99 times 10 to the power of 9 times 100 times 10 to the power of negative 6 divided by 1.2 to the power of 2. Which is going to give me 6.2 times 10 to the power of 5 Newton per Coulomb. And E2 is going to be KQ2 divided by R prime squared. That will be 8.99 times 10 to the power of 9 multiplied by 300 times 10 to the power of negative 6 divided by R prime is 0.2 to the power of 2. So that will be 8.99 times 10 to the power of 9 times 300 times 10 to the power of negative 6 divided by 0.04. That is going to give me 6.7 times 10 to the power of 7 Newton per Coulomb. So since E2 is greater than E1, we can say E net equals to 6.7 times 10 to the power of 7 minus 6.2 times 10 to the power of 5. That is going to give me around 6.68 times 10 to the power of 7. And it's Newton per Coulomb. And E net is going to go toward left because E2 is much greater than E1.